So, good morning, student. Today, I will discuss two simple methods that is called pressure jump and temperature jump method. I have already discussed the relaxation technique. I have already discussed the stop flow technique, and under this relaxation technique, this temperature and pressure jump methods are widely used for studying the fast reaction technique. And as you are aware that name itself is a definition. That means if it is a pressure jump with the help of some external agencies, we increase the pressure. Suppose the ambient pressure is 1 atmosphere. So, to perturb the equilibrium, we change the pressure and monitor the physical properties. Similarly, if it is a temperature jump method, then of course we increase the temperature with the help of some high voltage capacitor that will discharge the, and then temperature is increased 5 to 10 degrees centigrade, and we monitor the physical and properties. That is the pressure jump and temperature jump method. Fortunately, there is no complicated derivations are available, but you have to write the schematic diagram of this pressure jump and temperature jump method. This is a very simple method, Before as you know that you must refer, because there are, as I told you, there are many books available on the fast reaction, but basically only one Indian author has written these two books. I always mention his name, Professor Kallol, and Chemical Kinetic Methods. And also there is another book that is called Biophysical Chemistry, Techniques and Application. And in this book, there is one chapter that is based on the temperature jump and pressure jump method. So I have collected all the photographs from these two books, because if you see the Atkins and other books, they have given the information about the temperature jump and pressure jump methods, and of course there are some other research papers also, so you can get some of the information of that pressure jump and temperature jump method, how it looks like the method, instrumentation technique and other things. Now, I have already discussed the details of the, again I just want to repeat all those things, that there are two actually methods in relaxation method. One is competition method, sometimes it is called the direct method, and under this competition method, sound absorption technique is very suitable. And the indirect method, which is very important and most commonly used, so that is pressure jump, temperature jump and electric field jump. But today I will concentrate only on the pressure jump and temperature jump method. Now, it is up to you, or it depends upon the types of the instrument. So, we can monitor the conductivity, we can monitor the optical density, absorbance, we can monitor the fluorescence intensity, even we can use the light scattering method, even we can monitor the conductivity also, which is very simple, that we can measure the resistance and other things. So techniques may be different, but the properties are very common. Maybe pressure jump method, you can use the conductivity cell. In temperature method, we can use the conductivity cell. Or even in this method also, we can monitor the other things. आप सेकेंड पीरियड ले लीजिएगा, आप सेकेंड पीरियड ले लीजिएगा, सेकेंड पीरियड है. Now let me first discuss the pressure jump method. Now, as I told you, that name itself is a definition. So this is normal process, and you rapidly change the pressure. So naturally there is a disturbance in the equilibrium, and as you know very well, because I have already discussed the relaxation time and the meaning of the relaxation, that means the return of the system from relaxed state to equilibrium state. And during this change, you can monitor the, many times I told you. And if you see the recent technique, in earlier, during the time of Manfred Huygens and other things, people generally measure the conductance or the fluorescence, but now they are using the even NMR also. They are using the FTIR, CD also, circular diaphragm, everything. So this is the fundamental system. Now you must know, sometimes this is a very simple short answer question may be asked, what is the basic principle between the temperature jump method and pressure jump method? Basic principle. Because if you know, it is related to the equilibrium constant, and you know that equilibrium constant sometimes is temperature dependence and pressure dependence, and it was discovered by great scientist Van 't Hoff. So the basic principle is Van 't Hoff reaction, Van 't Hoff theory. But because here in pressure jump method we are concerned about the volume and other things, so we can monitor the molar volume also. And if it is a temperature jump method, we can monitor the change in enthalpy like that. So let me explain the theory behind the pressure jump method. No derivation, only you must know this thing. Now because it is related to the, suppose A is converted into B, same thing equilibrium method. So, and you also know that the relaxation time, after this class I will do some numerical problem, very simple numerical problem, then you can understand this thing. So it is reactants and it is product. So equilibrium constant we know, whatever it is, B by A. So therefore the extent of the reaction, because it is reaction, but the method is pressure jump. So how do I monitor the extent of the reaction? To monitor the change in concentration, but it depends upon the molar volume, delta V standard or like that. Standard molar volume, so for that we must know the heat capacity and other things. And when I have referred some of the original research paper, and you see that dy, because it is pressure dependence, natural log of K dP at constant temperature, of course it depends upon minus. There are other terms also, I'll show you. Standard volume divided by RT. There are other terms also, that is delta H, RT square. I will show you, but the value is So you see here. And I'm showing the original research papers. This is that paper you see here, dy dp of the equilibrium constants. But actually it is also depends upon there are two terms. There are two terms. One term is molar volume. One term is molar volume. But there are another term that is sometimes alpha V and volume, Cp, heat capacity, and delta H and RT. But whenever we measure the values of delta V and delta H, I think delta H is 10 kilocalorie per mole, and this alpha is coefficient of thermal expansion, and Cp you know, and the value of delta V and pressure jump is suppose 50 atmosphere. It is depends upon, it is not exactly 50, in between 50 to 60 or 60 to 70. But when we calculate these things, so the right hand side part values are very low in comparison to this term, around 10 times low. So therefore we will discard this part. So what would be the final formula? d by dp, change in pressure, natural log of K at constant temperature, is equal to only this dV0 by dt. Isn't it? So what is the basic theory behind this pressure method, pressure jump method? You must write this front of equation. And you can also mention these things that yes, we must consider the coefficient of thermal expansion as well as the change in enthalpy, but their values are very less in comparison to this. So therefore only this part. Now I am coming to that experimental part, which is very simple. Now, because we would like to change the pressure, so there must be some device by which we can change the pressure. Number one. Number two, when you just increase the pressure, so there is a perturbation of the equilibrium and return to the original state. So this particular change can be monitored with the help of oscilloscope or some other device, or to measure and you all know the simple principle of the Wheatstone bridge circuit. So this is the two part of this experimental setup. When I will show you this is the very simple schematic diagram of pressure jump method. And as I must confess that if you see the literature, there may be different types of photographs, but I have taken these photographs from the books of chemical kinetic method by the C. Kallol. Okay, so it is a schematic diagram in order to understand these things. So naturally, just like your stock flow method, there must be mixing. Here is no mixing system. So there are two cells like reactance 1 and reactant B. So this is called the conductivity cell. And it's very small amount, 1 ml like that. And second is the inert electrolyte like KCl. It is reference cell. Okay, 2 conductivity cell, and it will be kept under an autoclave. This is a box type of system, autoclave. And this green color, this autoclave is filled with some non-conducting liquid. Generally, because the old days, they use the kerosene oil like that. And there is a area, and earlier the atmospheric pressure is around 1 atmosphere, ambient. Now, how do I increase the pressure? By pumping the kerosene. Now again, it is a fast reaction technique, and you know that most of the time in relaxation kinetics, what we do, our half-life is just like, or relaxation time is microsecond, not millisecond, 1 into 10 to the power minus 6 seconds. So therefore, there must be some automatic device by which the pumping of the kerosene to increase the pressure within the 50 microseconds, because that is also important. So now you have seen that there is a dotted line here. Again, I am saying it is a block diagram, and that is a membrane. This is, suppose, is autoclave. There is 2 cells, and that is a membrane, and it was prepared, or it is a copper bronze alloy membrane, which is very thin, and of course it's really connected, and this whole system is connected with a oscilloscope as well as a potentiometer or whatever you can write. Now, as soon as we increase the pressure from 1 atmosphere to 60 to 70 atmosphere, there must be some barometer and other things. So there is a perturbation. How do we know that the pressure increases? This membrane burst. This indicates that the pressure is increased. As soon as this burst, automatic system, that this membrane burst or ruptures and oscilloscope is initiated. And we monitor the change in resistance with respect to time. Whatever it is, this type or this type or this type. So this is the very simple stoichiometric, or you can call it a schematic diagram of the pressure jump method. And theory is also very simple, using the one-top equation. We can monitor that type of resistance or the conductance change with respect to time. And then, of course, now again I suggest my student that you must see some of the literature and just write the instrument of pressure jump method. You will see different types of instrument for that. But it is to understand the system, I am giving the simplest method and taken from this kinetic method by Chetty Kalidas. Okay. And now I am coming to that temperature jump method, which is also very simple. Now, before going into temperature jump method, I just tell you that the basic principle is that as the pressure is increased, its equilibrium shifted to the maximum pressure, and there is a bursting of that membrane. And as per relaxation kinetics, you know that system again returns to the original state, and that type of diagram is called the relaxation oscillograph or oscillograph, to know the change in resistance with respect to the time. That is the theory. And if you see some of the books of the physics, you will understand. I am not going into details of the working of the oscilloscope, how it is related to the resistance and other things. But fundamental thing is that you have to monitor the changes with respect to time. That is the concept of the pressure jump method. Now, why I am saying that if you visit some of the fast reaction techniques laboratory, because after that I would like to discuss about the ultra fast technique, femtosecond spectroscopy, and in our country there are very few laboratories, like of course in Bhabha Atomic Research Center there is ultra fast technique. Then in Indian Association for Cultivation Science there is ultra fast technique, and I am very fortunate to visit that place when Professor Mihir Chaudhary was in charge of the physical chemistry. I went there and I have seen all this system of the fast reaction technique. Now I am coming to the temperature jump method. Now if you understand the pressure jump method, you can very easily understand the temperature jump method. The system is almost same. In temperature jump method, the perturbation or the change involves rapid heating or by increasing the temperature. So again there is a change in the equilibrium constant, and by relaxation method we can monitor that change temperature. But the important point is that here is also, as I told you my first part of this lecture, that any type of properties, absorption spectroscopy, fluorescence, light scattering, polarimetry, conductivity, only thing is that you have to set a system where the concept is the microsecond, not the millisecond concept. Now people are using the laser temperature jump. When I will discuss the femtosecond spectroscopy or ultra fast spectroscopy, now no old concept is not there. There is a laser spectroscopy, oil system, pump system, and other things. And because as you see in the pressure jump method also, we are taking very small amount, less than 1 ml. So due to the small volume involved, the temperature of the solution returns to the fraction of second, like that. Now again, anybody ask you that what is the theory behind this temperature jump method? Like pressure jump method, we are monitoring the delta V, molar volume. But here again same thing, because when a part of the equilibrium, so naturally equilibrium constant is affected. So when a single step of the reaction is perturbed, the reaction follows a single exponential decay function, of course with respect to time. And again it is called the, and I have taken from the literature, Wikipedia. Now question arises that how do you increase that temperature? How do you increase that temperature? What are the different heating methods? So although I am using very simple method, but I must tell you the other methods so that we can increase the temperature. Like Joule heating, dielectric heating. Suppose we increase the temperature of the solvent, heating by flash lamp, optical heating. But the most simple method is that there must be some high voltage capacitor, and that is actually release the energy, that discharge the energy, and that is the most important thing. And this method is very common, and again I am taking from this Professor Chetty Kalija's book. The heating usually involves the discharging of a capacitor. The rest things are very simple. There must be two cells, there must be some device, there must be some detector, everything is same. There must be some spark plug, everything is same. So let me explain the diagram. My students have prepared, Abhishek Katendra has prepared this diagram. Now you see, just you compare with the temperature jump and pressure jump method. So everywhere we need, whether it is a stop flow technique, flash photolysis, even NMR, everywhere we need some reaction vessel, mixing time and the mixing chamber. So similarly you see that there are two cells actually. This is cell. This is cell. This is cell. This is cell. So this is two cell and it is connected with a capacitor. And as I told you that it is also related with a high voltage source. So it discharge, and this voltage is, you see, 20 to 100 kilovolt. Now what is the difference between these two systems? That time we are measuring the conductance. But here, when we discharge this high voltage, so the temperature is increased, I think 5 to 10 degrees. And immediately there is a light source, there may be some monochromator, and this is a detector, photomultiplier tube and other things. What does it mean? System is same, only thing is that you are monitoring the change in absorbance, whatever the after the chemical reaction. So light source and it is detector. So it may be a fluorescence also, it may be a polarimeter also, it may be light scattering method is also. So this is the simple formula of the temperature jump method, and by that method you monitor the concentration with respect to time. And there are other types of jump cell also there. So actually there are two color, it is a solution, and this actually this is whole is a electrode. This is actually electrode. This is actually electrode. This is actually electrode. This is the whole part is electrode, just like the same thing. This is electrode, complete electrode. And then again same thing, you see, light source, and if there is a detector, same thing is like that. You see the system, it is also just like electrode. This solution is like that. This is also electrode. So that is also like that. So by that method you can monitor the temperature. Thank you.